Welcome to a new video series provided to you by Rohde and Schwarz. The series will be called Demystifying 5G, and we would like to discuss a few things around 5G with you: frequency candidates, requirements, timeline, waveforms. And today we would like to start with requirements and timeline. So 5G is the big buzzword that circulates through the wireless industry now for a while. But very often the question is asked, what is it? And there are many different ways how to answer that question. The ITU answers this question in the following way. First of all, ITU stands for International Telecommunication Union. The ITU is an agency of the United Nations whose purpose is to coordinate telecommunication operations and services throughout the world. Within the ITU, there's a group called IMT 2020. IMT stands for International Mobile Telecommunication, and that is a program in which requirements and scenarios shall be identified for a future generation of mobile technologies. There was a program called IMT Advanced that set the scene for 4G, called out the requirements that were then tackled by 3GPP's enhancements to the LTE technology called LTE Advanced. For 5G, there's now a program called IMT 2020. 2020 because it is kind of anticipated that by 2020, so in 5 years from now, there's a first rollouts of 5G networks. Within this program, certain high-level requirements were identified and can be organized in 3 major categories. First, and it's usual with any new generation of mobile communication, it should be better. Deliver a better user experience with gigabits per second as peak data rates and the average user data rate in the range of 100 plus megabits per second. Second, there's massive machine-type communications, often understood as the Internet of Things, short IoT. In these terms, think of what we can call a smart intelligent city with smart metering, lots of security sensors, basically devices that typically only transmit a small portion of data but need to have fast access to the network, an asynchronous type of communication with a long battery life. Last but not least, ultra-reliable and low-latency communications. Examples are the automated factory, industry automation in general, and autonomous driving. Basically the self-driving car that we all waiting for. Just by imagining that the application is that a car drives autonomously from point A to point B, demands low latency to exchange information between sensors and with the environment, and of course an ultra-reliable link between cars and its environment as we need it. So as we can see, a vast range of application with very different requirements. So these requirements are reflected on this slide. In particular on the right-hand side. The 3 different categories have set a different level of importance for key performance indicators, such as peak and average data rates, spectral efficiency, mobility, latency, and so on. And this is obvious, but of course has a tremendous impact on any physical layer and MAC layer design for 5G. On the left-hand side, you see a comparison of these performance indicators with IMT Advanced technologies, which is nothing else than LTE Advanced deployed in today's networks. These numbers show the theoretical possibilities of 5G in terms of peak data rates, for example. LTE Advanced is well capable going up to 1 gigabits per second and beyond, considering carrier aggregation of up to 5 component carriers with 20 megahertz of bandwidth, 256 QAM modulation, and 4x4 MIMO or 8x8 MIMO. Something we shall see maybe in 2016-2017 timeframe. IMT 2020 and therefore 5G needs to be better, of course. So IMT 2020 also provides us with a timeline that is shown here. The most important aspects are most likely the 2 World Radio Conferences, short WRC, where spectrum for 5G shall be discussed. The WRC 15 just ended in Geneva, Switzerland at the end of November. A first conclusion can be drawn about frequencies for 5G that we will discuss most likely in another video. From an industry standpoint, there are 2 important dates to keep in mind. The Summer Olympic Games 2020 in Tokyo, Japan. At that event, first commercial 5G deployments are considered. And there are even more aggressive dates available and announced by the industry. For instance, the Winter Olympic Games in Korea in Pyeongchang in 2018, where we already may see 5G networks up and running. Let's see what will happen. Because what we consider here is the standards. Standards as the third generation partnership project. And they have their very own schedule. So the standard work has officially been kicked off with the RAN workshop that took place about 2 months ago and was held in Phoenix, Arizona. So the workshop leads to a series of things. First, a series of study items impacted by the scope and 5G requirements that I just mentioned and discussed with you. This study items phase is stretched over quite some time, as one can see in the slide here, and is also impacted by another study item that just has been kicked off, which is on channel modeling between 6 and 100 gigahertz. We will come back to this in another video. The stretch in time can be explained with the different nature of the 3 major categories of use cases that we discussed earlier. The study items typically lead to several work items, which then become part of the specification at different releases of this standard. As you can see from the official timeline, there are 2 phases considered for 5G standardization. The first phase, targeting release 15, about 15 months long, with deliverables expected around September 2018. Experience tells us that it takes about 18 to 24 months to implement these deliverables in devices and networks, and therefore it can be expected that 5G networks are launched by mid-2020, end of 2020. Key design target is most likely enhanced mobile broadband at this time. Second set of work items, targeting release 16, will then include for sure IoT, ultra-reliable and low-latency communication, which should lead to a second deployment phase in late 2021, early 2022. Last but not least, also the LTE evolution will continue in parallel to the 5G standardization process. So the question is where we are with 5G, where we stand. And I really like this cone explaining the situation. So we are clearly at the 5G research stage with a lot of research being carried out by industry key players, by educational bodies like universities or research institutes, and so on. So there's a lot of prototypes, a lot of trials, a lot of people are right, not everybody is right. That's the kind of situation we are in. And we're working towards standardization, and then there will be more trials and so on. So again, 2020, that's the magic number. Thanks for watching. We hope to see you soon.